Hello everyone, today I will talk about functions basics as my second math term project. So let's start. So first of all, what is a function? The thing that comes to our minds should be or could be like a function machine as written here. In our daily life, let's suppose this as an input hole and output hole of a machine, and this machine is a cake baking machine. So as an input, we can put like egg, milk, yeast, and maybe dough and several different type of like food into the as an input, and we would get cake as an output. As this metaphor in math, we are going to put like numbers and variables, values. So let's suppose we put 2, or let's just start with x. We will get 7x out as an output because the machine is a 7x machine. Anything that you put as an x, you will get 7x of it. So if we put 2 as an input, we would get 2 times 7 times 2, which is 14. In math, the notation of this is shown like here is this. This is the function symbol f. It can be g, it doesn't matter at all, and x in here is an input, and 7x is recognized as the output. So let's move on. The relation with mapping and function is very high. While explaining it, many people use it, and teachers as well. So these are, as you can see, two sets. We will do mapping from the elements in set A with the set B, and while doing this, the process between this will be called function x. Let's start. Let's suppose A1 goes to B1 and A2 goes to B2 and also A3 goes to B4. This can be considered as a typical function. What we've done now is the domain. We map the domain elements here in set A with the element set B. But maybe if you carefully watched it, you see that we didn't map B3 with an element in set A, which also in function there are specific names for it. Where the arrow starts is considered as domain part, and where arrow finishes, the result of it is codomain. In set A, the elements are domain, as you can see, it's written here A1, A2, A3, and the codomains are B1, B2, B3, B4. But the problem is all of the codomains are not mapped. So what we will do now is another thing. We will find the range. The range is the mapped ones. The empty ones will not be considered or included in range or image. The image will be B1, B2, and it's a mistake, B4. Not B3, right? Because B3 is not mapped. And this process is called function. Another crucial point is, let me show it very quickly. Let's finish it like this. This would not be a function. The reason is there is an empty element in the domain part, which is not possible for a function. Every element should be mapped, so we cannot left any elements here. We can also map A3 with B2, like two elements in domain can go to one element in codomain. It's possible. What is not possible is, let's say A3 goes to B4 and A3 also goes to B3. This is not possible. An element in codomain cannot go to two elements in codomain. It's like a baby has two mothers. It's biologically not possible. Let's continue with two questions. We will find the values of functions. So the question asks, what is the value of function 3? This is the function. We will replace 3 anywhere where the x is present. So you will write 3 cube plus 7 times 3 plus 4. The rest is very simple. 27 plus 21 plus 4, and this will give us 48 plus 4, which is 52. Let's continue. Question 2 is if 3x minus 1 equals to 6x minus 5, what is the value of function 7? So this is a tricky one. We need to find the value which gives us 7 in 3x minus 2. Let's write the equation. 3x minus 2 should be equal to 7, and it will look like this. When we simplify it, x would be 3. The rest is easier. 6 times 3 minus 5, and it will be 18 minus 5, giving us the answer as 13. So function 7 is 13. Let's continue. Identity function. What is an identity function? Identity function is a very simple and easy thing. It means domain is equal to the range. Anything that you put into as an input will be equal, the output will be equal to the input. To show it, let's solve some maybe examples, exercises. Function 5, if it is considered as an identity function written as here, it will be 5. Function 21, 21. Function minus 5, minus 5. Function x minus 79 will be, 79. On graph, it will be shown as a linear graph like this. Let's move on. Constant functions. What is a constant function? In constant functions, domain should, all of the domains will be equal to one and only one number, constant. As written here, let's say fx equals to minus 1. Anything that we put in x will give us minus 1. So function 1 will be minus 1. Function 3 will be minus 1. The rest is, as you can see, minus 1. On graph, it will be drawn as a horizontal line. Let's suppose here as minus 1. I hope I could explain it. Let's continue. Question 3. mark the ones which are not a function. To find the function, to understand whether it's a function or not, we need to do a test. It's called vertical line test. If it intersects in two different points, then it's not a function, but if it intersects only in one point, it's a function. Let's quickly do this. When we draw a vertical line, it intersects only in one point, so it's a function. If we draw a vertical line, it intersects only in one point, so it's a function. For the third example, when we draw a vertical line, it's also a function, as you can see. But for the fourth one, this is critical. When we draw a line, a vertical line, as you can see, it intersects in two different areas, points. So it's not a function. Okay, so the fifth one, when we draw a vertical line, it intersects on both two sides. It's not a function. The last one is a very critical one and tricky one, actually. Sorry, tricky one. The reason is because it's not just a linear graph or anything like that. You can't see lines appropriately, so we need to look it very carefully. If you look at carefully, you would see two dots on the same vertical line. When you draw a vertical line here, you would see two different intersection points, which shows us that it's not a function. Because if it was a function, then there shouldn't be two intersection points in anywhere vertical line. Therefore, this is not a function. Thank you for listening me. I did my best. I tried to explain all the details as much as I can, and I completed my second math term project. I hope you liked it. Thank you for listening. Have a nice day.